Hello everyone. The title of this video is Create a Function by Composition of Functions. And every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. And I'm in their Algebra and Trigonometry text, section 3.4, Composition of Functions. And I'm under the heading Create a Function by Composition of Functions. Alright, so each example I'm doing is either going to be an example from the reading or one of the try it problems throughout the reading or one of the exercises at the end of the section that's related to this particular objective. Okay, so I have my examples written out on paper. And we're asked to, use the given functions to find the composite functions. All right, so I want to talk about what that means. Pardon me. So we're given two functions, f of x equals x squared plus 1, and another function called g, right? G of x equals the square root of x plus 2. And here's notation for what's called a composite function. Right, a composite function. It's a new function, right? It's made up of two old functions, right? We're given the old functions f and g, and we're asked to make some new ones. But instead of adding, subtracting, multiplying, or dividing, we're going to be doing what's called composing the functions. And that's what this little O symbol stands for in between the f and g. This new function is called f composed with g, or f of g. All right, so the little O symbol, pardon me, means composed with. It's called the composition operator. Composed with. And here's how composition works. Here's how composition works. You go kind of right to left. You go right to left in the way that this is written. Right? Or some people might say inside out. But you take the input x. Right? So whatever my input is, I take the input x and I plug it in. All right, plug into the first function, which is g here. Right. So I take x, and then going right to left, I plug x into g, and that gives you g of x. Right. Then you take g of x. Right, you take this output that you just got, g of x, and plug that into f. Right, or you plug it into the next function over. So I first take x, plug it into g, then I take g of x and plug it into the next function over, which is f. Plug into f, which will give me f of g of x. Right, so g of x is put into the output from g becomes the input for f. And in fact, what I've just written here that I'm pointing at is another way to write function composition. So f composed with g at x is the same as saying f of g of x, like this with all the parentheses. They mean the same thing. Alright, so let's see how this works here. Alright, well, for this particular example. So I'm going to do this so I actually have room for part B. So yeah, so you take x and put it into g. Right, g of x is the square root of x plus 2. Right. And then I take this and put this into the next function over. Right? I take the square root of x plus 2 and I plug this into f. Right? And we get f of g of x, or f composed with g of x. This would be f of the square root of x plus 2. Right? Whatever g was becomes the input for f. And then remember how function notation works. This means I go to function f and replace all the inputs. I replace all the x's with this square root of x plus 2. So remember, f of x was x squared plus 1. Well, instead of x, right, I'm replacing the x's with this square root of x plus 2. So instead of x squared, it is the square root of x plus 2 squared. And then you have plus 1, don't forget. Alright, and then we simplify. Now remember, the square root of something to the second power, the square root's gone. So this is just x plus 2, and then you got plus 1, or x plus 3. Alright, and there you go. This is our final result here. This is the resulting composite function. Right, so f composed with g at x will result in x plus 3. Right, and that's all that we're being asked for. So let me show you an example with an actual number to show you to show you how this works, how this works here. So for example, if x were 2, let's say, if x were 2, according to this, according to what I have circled here, the value of this composite function, this f composed with g at 2, would be 2 plus 3. Right, would end up being 5. Well, let's see if that works out, going through the long way. Right. F composed with g of 2, remember, another way to write this is f of g of 2. So remember how this works, right? The way I described it. You take 2, you put it into g. Right, g of 2 is the square root of 2 plus 2. That's the square root of 4, which is 2, right? So I'm going f of 2, right? G of 2 is also 2. And then I take that 2 and put it into f. And f of 2 would be 2 squared plus 1, which is 4 plus 1, which is 5. Exactly what I said it would be here with this rule I circled earlier. And again, you can plug in really any numbers as long as you get real number outputs. Alright, I can't plug in like -3 because I'll be taking the square root of a negative, but how about if x were, let's make 7 for an easy square root. If x were 7, according to this rule I've circled, f composed with g at 7 should end up being 7 plus 3, right? Should end up being 10. Well, let's see if that works going the long way, right? This would be f of g of 7. So remember, first you go into g of 7. Plug 7 into g first. Now g of 7 would be the square root of 7 plus 2. That's 3, right? The square root of 9. So this becomes f of 3, right? Then I take 3 and plug that into f. All right, it's just a series of consecutive substitutions, really. Just a lot of subbing. And then what's f of 3? F of 3 would be 3 squared plus 1. right? Go to function f, and that's 9 plus 1, that is 10, right? Exactly what I said it would be using the rule I found earlier. Okay? Yeah, but again, it's just a series of successive substitutions. You want to say it that way. So f of g of x is plug x into g, then plug g of x into f. Just keep going right to left, right? Right to left. Or inside out, as some people say. All right, so that's part A, right? F of g of x is x plus 3. Totally new function. Well, what about the other way around? All right, so part B, given the same two functions here, right, now we saw, I'll write this out one more time over here. We saw that f composed with g in that order takes x to x plus 3. All right, this is what we just saw. Here the order has changed for part B. Notice it's g composed with f at x. So in this, x, my input x, I'd plug into f first. And that would give me f of x. And then I would take f of x and plug it into g to give me g of f of x. All right, so another way to write this is g of f of x. Same thing. Okay, well, what is g of f of x? Well, first I'm plugging x into f. All right, so find f of x first. That's x squared plus 1. So this would be g of x squared plus 1. Right? Because I plugged x into f, got x squared plus 1. And now I'm plugging x squared plus 1 into the next function, which is g. And remember, how do you do function inputs, right? X squared plus 1 is replacing x in the rule for g. So instead of the square root of x plus 2, it's the square root of x squared plus 1 plus 2. It's replacing these x's with x squared plus 1. And then if you simplify, that's the square root of x squared plus 3. And there you go. There's the function g composed with f at x, right? Right, so this time, if you were to plug in 2 for this, g of f of 2, so some examples. G composed with f at 2, according to this rule, would be the square root of 7. But remember earlier, when we had the other order, f composed with g at 2 was just 5, not equal. Definitely not the same expression, these. G composed with f at 7. Just replace x with 7, 49, 7 squared, 49 plus 2 is 52. That'd be the square root of 52. Earlier, we did f composed with g at 7, that was 10, not the square root of 52. So these are definitely different. F composed with g is definitely different than g composed with f in this case. And that's going to happen a lot. You're going to notice that the order of composition matters, right? So let's take a look at these again, right? F composed with g at x was x plus 3. G composed with f at x was the square root of x squared plus 3, like that. So yeah, the order matters in composition. F composed with g is not always equal. as g composed with f. Now there are some cases where they are the same, and we'll talk about that in a later video. Alright, when does switching the functions still give you the same result? But you'll see for most of these examples, switching the order will change the function, will give you a totally different function. Alright, so this is huge here. Please pay attention to this. Alright. Okay, great. Alright, so let's just keep doing this. I got a few more pages here with some more examples of creating these composite functions. Alright, so in example 2, given two functions, again f and g, we have f of x is the absolute value of x, and g of x is 5x plus 1. Part A, I want to find the function f composed with g. What's f of g of x? And again, another way to write this is just with a bunch of parentheses, right? This is f of g of x, right? F of g of x, right? And then all those parentheses there. Okay, so first x goes into g. Right, first I find g of x, right? X goes into g first. That's going to be f of, and then g of x we see up here is 5x plus 1. And then I take that 5x plus 1 and put it into f. So if I put that into f, that just means the x's in the f rule get replaced by 5x plus 1. So instead of the absolute value of x, it's now the absolute value of 5x plus 1. There you go. There's f composed with g of x, the absolute value of 5x plus 1. And then part B is just the other way around, switch the order. What is g composed with f of x? And again, another way to write this should be g of f of x, like this with all the parentheses. So first, so this time x goes into f first. Alright, so I find f of x first. Now f of x is simply the absolute value of x. And then you're plugging that into g. Alright, now it becomes g of the absolute value of x. So this means go to the function g and replace all the x's, replace all the inputs with the absolute value of x. So instead of 5 times x plus 1, it's 5 times the absolute value of x plus 1. And there you go. And these, notice again here that these are totally different expressions. Alright, these are totally different expressions. They're not the same function. And I can show you one example here. Here f composed with g at -1 would be 4, wouldn't it? Right? If I plugged in -1 for x, -5 plus 1 is -4. The absolute value of -4 is +4. But if I switch the order, right, do g composed with f at -1, the absolute value of -1 is 1 times 5 is 5 plus 1 is 6. See how these are not the same all the time? I mean, they would be the same for positive values of x or non-negative values of x, but for negative values of x, they're different. Alright, so we're seeing here that f composed with g, that function is not equal to g composed with f, when x is negative, right? But we'll just say they're not equal, right? Because the only way two functions are equal is if they have the same value for every value of the domain. And again, you're going to notice this a lot, that when you switch the order, the composite function changes. You get a totally different composite function. All right, let's do that again. So another example where we're given a couple functions here, f and g. F of x equals 1 over x minus 6. G of x equals 7 over x, and then plus 6 after. And once again, we're just asked to make two composite functions, right? One f composed with g composed with f. Right, so the first one, f composed with g. Again, I like to write it with the parenthesis form. This is f of g of x. And again, in the order that things come in, you take x and you plug it into g first. Right, so what's g of x? G of x is written here. That's 7 over x plus 6. And then we take this 7 over x plus 6 and put it into f. Right. So now I'm finding f of this 7 over x plus 6. So basically just go to the rule for f and replace all the x's with this 7 over x plus 6. So that'd be 1 over, and then instead of x, we have 7 over x plus 6. Right, and then minus 6 after. Well, we're definitely going to have to simplify this, right? This is just 1 over, and then 7 over x, right? Because the 6's would cancel, plus 6 minus 6, and then anytime you divide, you're multiplying by the reciprocal, so this will just be x over 7. This just ends up being x divided by 7. All right. So if you were to plug in 7 for x, the output would be 1 for this function called f composed with g, or f of g. Or if you were to plug in 14 for x and do all this process, you'd end up with 2, right? 14 divided by 7, and so on. All right, then let's take a look at the other function, right? Let's switch the order and see if we get the same function back or not. Right? Again, I'll talk about in a later video when will switching the order not matter, but most cases it will. All right, so we have g composed with f of x, right? Or g of f of x. And again, how this works is the input x goes into f, right? So first we find f of x. First we find f of x. Well, f of x is given to us. That's this 1 over x minus 6. And then this 1 over x minus 6 now gets plugged into g. Right, so I'm taking g of 1 over x minus 6. So just go to the rule for g and replace all the inputs with this 1 over x minus 6. So that's 7 divided by, and then instead of x, this 1 over x minus 6. And then you have plus 6. Okay, and then doing some simplification here. Right, instead of 7 divided by 1 over x minus 6, that'd be the same as 7 times x minus 6 over 1. Right, and then we have plus 6. And distributing the 7, and we get 7x minus 42, but then plus 6, it'd be minus 36. And there's the resulting function there. So definitely not the same expression. Right? These definitely have different values when you plug in certain different numbers, the same numbers. So here if you were to plug in 0, you'd get negative 36. Over here if you were plugging in 0, you'd get 0. Right. Well, actually, you couldn't plug in 0 over here because you'd have 7 divided by 0. So that definitely makes these not equal. My apologies. Yeah, if you were to plug in 0 here, it'd be undefined because of this 7 divided by x part. Still, hopefully it's clear that these are definitely different functions. Right? So pay attention, right? Order matters when composing. Okay, so hopefully the process is making sense. And now we're just going to add to it a little bit. I got just one final example. So far we've only composed 2 functions at a time, but you can compose as many functions as you wish. So here I have 3 functions, f, g, and h. And I'm asked to make a composite function, make a totally new function called f composed with g composed with h. And what happens at x, right? So f of g of h of x. So that's a way I can write this. Right? This will be f of g of h of x. And just close all the parentheses. Right? And you do the same thing as with 2 functions. It's the same process. It's just one extra step. You take the input x, and you're just going right to left or inside out. X goes into h first. Right? So first we find h of x. Now h of x is the square root of x. Right. Then this gets plugged in, h of x gets plugged into g. And then that will get plugged into f, right? So I still have f here as well. Right. Alright, so first I plugged x into h, giving me the square root of x. And then I plugged the square root of x into g. Now if we plug the square root of x into g, that would give me the square root of x minus 6. Right, replacing x with the square root of x. And then I take this and plug it into f. Right, so now we're taking f of the square root of x minus 6. So I go into f and replace x with the square root of x minus 6. So instead of x to the 4th, it's now this. It's this square root of x minus 6 to the 4th, and then plus 6. Alright, and that's as good as I'm getting. Alright, now you can expand this. You can take the square root of x minus 6, to the 4th power, multiply it by itself 4 times. That would just take a while. Or if you know the binomial theorem, you can expand this pretty easily. But this is the way I'm leaving it. And then just to test it out a bit, I'm going to try some numbers. All right. A nice number here would be, what if x were 36? If x were 36. Now according to this rule, f composed with g composed with h at x equals 36 would end up being 6, right? Because the square root of 36 is 6. 6 minus 6 is 0. 0 to the 4th is 0 plus 6 is 6. Okay. But let's try that out now here. Right? F composed with g composed with h of 36. Again, another way to write this would be f of g of h of 36. Alright, now h of 36 I'll do first, right? So this would be f of g of h of 36 would be the square root of 36. Move that down. Square root of 36, which is 6. And then I find g of 6. So this would be f of, and then g of 6. Well, g of 6 would be 6 minus 6. That'd be 0. And then what's f of 0? F of 0 would be 0 to the 4th is 0 plus 6 is 6. And that's exactly what I told you it would be up here using our rule. Right. Now again, you could do this for anything, any number, except for negative numbers, right? Because the first function we're plugging into is h, the square root of x. So you can't plug in negative numbers. That'll be imaginary, square root of a negative. But for any number 0 or greater, this will work. Right? This is a good rule. Alright, I'm hoping the procedure makes sense after watching me go through these 4 examples here. When you see this little O symbol, the composite symbol, you're just going right to left. You're just going right to left. Alright, you plug x into the first function, then take that output, plug it into the next function, then take that output, plug it into the final, however many functions there are, just keep going right to left until you're done. And after some practice, I feel like it's pretty easy. Alright, I'm hoping that watching me go through these 4 examples helps you in some way when you're asked to create a function by composite or composition of functions on your own. And thank you very much for watching.